Hello, this is Lab 2, Charge Tapes Continued. This lab is basically a continuation of Experiment 1, where in Experiment 1 we determine the interactions between clear pieces of tape and other objects, and we determine the excess charge on one piece of tape, and we assumed that the charged pieces of tape acted as single point charges, and we simulated these interactions with a computational model using Python, and we found that the charged piece of tape had positive charge of 2.24 times 10 to the negative 8 coulomb, and the tape was deficient of 1.4 times 10 to the 11 electrons. Some key concepts from this lab include Newton's second law, which is that the sum of the forces equals mass times acceleration, Coulomb's law, which is basically the electric force, and then in this lab we're using the electric field of a rod because we're going to simulate the charged piece of tapes as basically a rod with uniform charge density. And so this considers both the separation distance between the point and the length of the tape. We're going to be making 3 key assumptions in this lab, and those are that the charge of the tape is evenly distributed along the length of the tape, so the code can be basically modeled as a line of point charges instead of a single point charge, and we're ignoring air resistance, and we're assuming the 2 tapes have equal charge. So to recap on the observations from Lab 1, we saw that the 2 U-tapes repelled each other, and U-tapes in the hand attracted, which from this we determined that the U-tape had a positive charge, and therefore it had lost electrons through the charging process. Here's a free body diagram of both pieces of tape, and we can see the suspended U-tape on top has the electric force pointing up from the held U-tape and the force of gravity pointing it down, whereas the held U-tape has a holding force pointing it up and the electric force from the suspended U-tape pointing down. Here's an overview of the data and calculations from Lab 1, and this is where we determined the charge of the tape to be 2.24 times 10 to the negative 8. So since the focus of this lab is calculating the charge with a uniform charge distribution assumption, we're going to first set the force of the electric force equal to the gravitational force, and then using an equation we learned in lecture for the electric field of a rod, we can rearrange that equation to basically solve for Q, and this will tell us the electric field of the charged rod, and we're going to assume that the other piece of tape can be modeled as a point charge, which will be the observation point. Here are some screenshots from the computational model. We set some constants, which include the Coulomb's constant, gravity, the mass of the tape, and the initial charge, or the guess for the charge, which we got from last lab. And so we start by finding the electric field, and we do that basically from those constants and making the point charge equation. And then the next part of the code, which was basically done for us to find the line of, or to model the line of point charges. Here is more of the code, and this is sort of how the electric field and the gravitational field were calculated, and also modeling the arrows based on the magnitude of each forces. And here are the results of the computational model. So on the left you can see with the point charge assumption from last lab, you can see that the difference between the electric force and the gravitational force is pretty substantial with the 2.24 times 10 to the negative 8 charge assumption. And then when I calculated the new charge of the rod due to the uniform point charge distribution assumption, I got that the forces were, although not equal in magnitude, were relatively close. So this shows that the rod uniform charge assumption was a much greater assumption than the point charge. And then in order to calculate the actual charge of the tape, I did a little guess and check to make the forces of the electric force and the gravitational force about equal to each other. And from guessing and checking, I got that the actual charge of the tape was about 3.52 times 10 to the negative 8 coulomb. So finally, the charge of each tape according to the line charge assumption was 3.23 times 10 to the negative 8 coulombs, and therefore it was deficient of 2.78 times 10 to the negative 11 electrons. And some possible sources of error in this experiment are inaccurate measurements of the tape length, the tape height, and the separation distance, as well as handling of the tape, and the tapes not being parallel to each other, as well as some rounding errors. So for the what if discussion, if I had modeled each of the tapes as a single point charge like the previous lab, it would have made a considerable difference, and the factor was off by about 1.44, so which is pretty significant. And then why did these estimates differ so much? And then which value is likely to be closer to the real value and why? The line charge model takes more like real aspects into consideration, including the length of the rod and the fact that charge is distributed like across a material and not just at a single point.